This is 28 from 2.2. We have a function y equals 0.25x to the fourth, and we'd like to use indir, the numerical derivative, to graph. And we remember that in the graphing calculators, this is known as inderiv. And if your calculator is in math print mode, it will be in ddx of our function evaluated at x equals a number mode. So let's pull up our calculator and see if we can use this to graph the derivative. So we hit the y equals button, and this is normally where we would type in our function. But in this case, we're going to go directly to the math button and use option 8 in deriv. So we're telling our y1 equal to graph the derivative of a function. We want to graph ddx, the derivative with respect to x, of the function 0.25x to the power of 4. Now, here's where we have to kind of take a step in a sideways direction. Normally, what we do is type in a number here. We want to evaluate the derivative at a constant value. But if we did that in this case, all we'd have is a horizontal line. We'd be graphing y equals a number, the numerical derivative at whatever x value that the function found. Right now, what we're going to do is tell it to graph the derivative at every x value, at x equals x. And so what the calculator will do is calculate the numerical derivative value at each x value along the x-axis, starting from the left and going to the right, and plot all those values so that we have a graph of the full derivative. So let's go zoom decimal and see what we get. Generally, this takes the calculator a little bit longer to work and graph because it's working quite a bit harder calculating the numerical derivative at each x value. And there we have the graph of the derivative of this function. So we can almost label this as y prime. And there's a follow-up question. See if we can identify what function this is. This is pretty clearly the cubic function, and I think I would even go so far as to say y prime at the least is approximately equal to x cubed, and we should find out soon that y prime is equal to x cubed as well. So there is our graph. We would want to give a little sketch of that, and here is our estimation of y prime.